For 10.3, we have systems of linear inequalities. This might sound familiar to you because it says systems of linear, but notice the statement ends with the word inequalities. That's because today when we look at our systems, they are going to have equations that have less than or greater than symbols, or less than or equal to, greater than or equal to symbols, meaning inequality. That's what that word means when you see it. Let's take a look at what we have here. System A is something that we are familiar with. It's a system of linear equations. If you remember, the way to solve a system of linear equations is if you can find where they intersect. So that's, on this example, it would be the point 2, 5. And what that means is if you plug 2, 5 into these equations, both will be true statements. So plug 2, 5 in, see what happens. 5 equals negative 2 plus 7. Is that true? Yeah, 5 is equal to 5 then. That makes a true statement. And if I plug 2, 5 into my next equation here, 5 equals 2 times 2 plus 1. Is that true? 5 equals 2 times 2 plus 1? Yes, it is. 5 equals, well, that's 4 plus 1. Yeah, 5 equals 5. It's a true statement. So let's go over to the inequalities. If you notice, y is greater than negative 3x plus 4 is graphed using the yellow and purple. It's graphed up this direction. When we graph inequalities like this, we have to pick the point, and if it works, you shade on that side, and if it doesn't, you shade on the other side. And that's what this person did, and then they went back and they looked at the equation y is less than 2x minus 6, and they graphed that one, and that would cause you to shade down here. If you notice, where those shadings overlap is this section here. Anything going this way into the universe. That means that area holds all of the points that make both of these equations true. Don't believe me? Plug in a point. Try the point, I don't know, 5, 0, maybe? That point right there. Plug it in. My x is 5, my y is 0. Is 0 greater than negative 3 times 5 plus 4? Let's see. 0 is greater than negative 15 plus 4. Is 0 greater than negative 11? Yeah. So that point works. And then let's see, does that point work in the other equation also? Is 0 less than 2 times 5 minus 6? 2 times 5 is 10, right? 0 is less than 10 minus 6. What's 10 minus 6? 4. Awesome. Is 0 less than 4? Yeah. So if I go through, I can plug in any of these points over here, any of them, and they all make both equations true. So that's why the inequalities that you're doing today, the systems of inequalities, are going to look like that. Let's take a look at some examples. I need to graph these equations just like I would if I were graphing, I need to graph these inequalities just like I were on my homework last time. So I'm going to go to my negative 1, and then I'm seeing a slope of negative x. So I'm going to get some other points on my line. Notice I'm doing open dots because this is not a greater than or equal to symbol. If it was a greater than or equal to symbol, then they would be closed in. We'll get to that in a second. So those are my points on my line. I connect it with a dotted line because the same reason for the not having or equal to in my inequality symbol. And now I plug in a point. Let's try 0, 0. Is it going to make the equation true? I'll plug 0 greater than negative 0. Is 0 greater than negative 1? Absolutely. So I'm going to shade on this side of the line for that one. And now I need to go through and do that for my next equation down here. So we got this one going on. I need to plug in some points, plot some points, and my slope is 1. Dotted line. Test a point. Let's try 0, 0. Is 0 less than 0 minus 5? Is 0 less than -5? No, it's not. So do not shade on the side that includes 0, 0. That's over here on the left side, so I need to shade this way below this guy. And if I look, this section right here is the part that has been shaded when I graphed both, so that's where I'm going to get my solutions. That's the area for my solutions. And in my steps, I asked you to plug in a point that's in that section just to make sure. So plug in, I don't know, the point, just pick one over there and test it out. I'm going to do the point 1, 2, 3, 4, 5, 6. I'll do the point 7, 0. I'm seeing it right here along the x-axis. Is 0 greater than -8? Yes, it is. Good, so it works for the top one. And then if I plug it into 0 less than 2, yes, it is, so it works for that one. And then go ahead and do the same exact process on this one. I'm seeing an inequality symbol without an or equal to sign, so I'm going to make sure that I do not fill in my dots. And then the slope is 1/3. Dotted line. Test the point 0, 0. Is 0 less than 7? Yes, it is. Shade on the side was 0, 0. For my next one, I'm seeing or equal to, so that means I get to plug in my dots, or fill them in. So I'm going to plug, or fill in my points. I keep saying the wrong word. What the heck? Okay, it's all good. It's not like you haven't heard me mess up every single word in a sentence before. Okay, 0, 0. If I plug in 0, 0 here, I get 0 is greater than or equal to -0 plus 4. And you can use whatever number you want. I just think that 0, 0 is the easiest thing to plug in. So if you like ones or hundreds, do your thing. Alright, is 0 greater than 4? No, it's not, so I do not shade on that side. I need to shade on this side up here. Now, my overlapping section is right here, so that's where my solutions are. They're right here. Plug in a point. I'm going to do 3, 3 because I'm seeing that that point right here is going to be really easy to plug in with my 1/3. So, is 3 less than or equal to, or sorry, just less than. Well, see, you know what I mean? Sometimes you just say the wrong word and then you just fix it. And then it's permanently on YouTube and everybody loves it. Is 3 less than 8? Yes, it is. So that point works with my top equation. If I plug it in here, 3 is greater than or equal to -3 plus 4. 3 is greater than or equal to 1. What's that? 1. There we go. Is 3? Yeah! Woohoo! We did it. Anyway, you guys are the best. I miss you so much. I hope you have a great day.